All right, diving right in today. We're going to tackle something super essential in the database world, SQL joins.
Yeah, really at the heart of relational databases. It's
Yeah.
how you bring all that data together, right? And we'll be uncovering those relationships too.
Absolutely. It's about making sense of it all. And we want to make sure you can pull out those real golden nuggets of insight.
Exactly. Whether it's customer data, employee records, or even, say, keeping track of all your products, this deep dive, it's going to give you the tools.
The tools to kind of weave it all together. So by the end of this, you'll be fluent in join types. You'll know how those relationships between tables work. And we'll even hit on some best practices to make those queries sing.
Yeah, I think what's so cool about relational databases, it's not just about, storing the data. It's the connections you make.
Right. It's the connecting.
It's like having this hidden superpower where you can take these, separate bits of information and turn them into something much bigger.
Okay, so picture this, right? You've got a table with all your customers, each with their unique ID, their customer ID.
Hmm.
And then you have this other table, right, with all the orders. And of course, you're using that same customer ID to connect them back to the customer who made the purchase.
Right.
How do you see who ordered what?
Yeah, how do you make sense of that data?
That's the magic of joins. That customer, it's the bridge, the link between these two different stories.
Absolutely. And it's pretty simple piece of SQL code that brings this to life, really. It looks like this. Select customers.name, orders.orderdate. From customers joy on orders, on n, customers.customerid, and orders.customerid.
So that little snippet, that's a join in action.
Right. It's telling the database, hey, find the matching customer IDs and bring me back the names from the customer's table and the dates from the orders table. Connect the dots.
So a join, it's like this operator in SQL that acts like, I don't know, maybe like super glue for data.
That's a great way to put it.
You're taking rows from different tables. I mean, our example uses two, but you could be joining many more.
Yeah, that's good.
And you're sticking them together based on this common piece of information, right? That related column we talked about.
Exactly. And that shared piece, that customer ID, it's what lets these different bits of data make sense together.
Like a handshake.
Right, like a handshake.
So in that first example, joining our customers and orders tables, we're using the customer to pull in the customer's name from one table and the date of their order from the other.
Right.
Now we're not just looking at a list of customers or a list of orders. We actually get this combined view of who bought what and when.
You start to see the story unfold.
Yeah.
And it's really exciting, because this seemingly simple idea, this joining of tables, it opens up a whole world of possibilities for analyzing your data. You're not just listing things anymore. You're uncovering relationships. You're seeing dependencies. You're understanding the flow of information.
So joins are like the key to unlocking that deeper level of insight.
They really are.
No, it's not a one-size-fits-all situation, though, right?
Right.
There are different types of joins, and each one's like a specialized tool, right?
Exactly. And each one is going to help you retrieve a very specific kind of information.
Yeah.
So choosing the right one, it's super important for getting accurate results.
Okay. So let's unpack those different tools. First up, what about this inner join? Why is that one so popular?
Well, the inner join, it's very straightforward.
Yeah.
It gives you back rows only when there's a match in both tables. So if you have a customer in your customer list, but they haven't ordered anything yet,
Yeah.
they wouldn't show up in an inner join.
Okay.
Same goes for the other way around. An order without a matching customer, nope, not going to see it.
It's got to have a match in both, right?
It's got to have a match in both.
Yeah.
Exactly.
Yeah.
So, think of it as the no-nonsense option.
Gotcha.
It's only showing you data where the connection is solid, where it's verified on both sides.
Yeah.
And that's really useful when you're building reports where you need that guaranteed link.
Okay, so it's like saying, show me the customers, but only if they have orders too. And in SQL, we'd write that as select customers.name, orders.orderdate from customers inner join orders on customer, customers.customer, orders.customerrid. We're specifically asking for that inner join.
Exactly. And that inner join keyword, that's what tells the database exactly what we want. It's a very precise. It's giving you just that overlap between the two data sets where that link exists in both.
So what if we want to see all our customers, even the ones who haven't spent a dime with us yet?
Yeah.
It seems like the inner join wouldn't cut it, right?
You're absolutely right. For that, we've got something called a left join, or sometimes you'll see it as left outer join.
Okay.
It's designed to give you everything from the left table. In our case, that would be the customers table. And then it adds any matches from the orders table.
So we see all our customers first and foremost.
Exactly. And then we see if they have order data too. It's a
Yeah.
really good way to get a complete picture. See who your customers are and if they've bought anything.
So everyone in the customers table, they're definitely in our results.
Right.
But what happens to those who haven't ordered?
Well, for those customers without orders, the columns that would normally show their order details, they'll just have this special value called NELL.
NUL.
Think of it like a placeholder. It just means, hey, there's no order information here.
So it's not like an error or anything?
No, not at all. It's just a way of representing that lack of data. And that way, you get this nice, complete list of every customer. And for those who have ordered, you see their order details alongside their name.
So the query for that would be select customers.name, orders.orderdate from customers left, join orders on customers.customerid, orders.customerid.
Right.
Spot on. And we'd see our list of customers. And for those with orders, we'd see the date. But those without, that order date would probably just be blank.
Exactly. Blank or NELL.
Makes sense.
It's super useful when you need to see the full scope of one data set, in this case, our customers, and then to just check if there's any related data, like orders, without excluding those who don't.
So if we have a left join,
Uh-huh.
I'm guessing there's going to be a right join too, right?
You got it.
Has to be.
You're absolutely right. There's a right join, and it's pretty much the mirror image of the left join. It gives you all the rows from the right table, which in our example would be the orders table, plus any matching rows from the customers table.
So with a right join, we see every single order.
Yep.
Whether it has a customer attached or not.
Exactly. And if there's a matching customer for that order, those customer details, those show up as NL.
And the query would be select customers.name, orders.ordernate from customers right. Join orders on customer, customers.customerid, orders.customerid.
Precisely.
So is that a common use case? The right join, it seems like maybe less common than the left join, right?
You're right. It is a bit less common, especially in, the typical data analysis where you're often focused on your customers or your products. But there are times when it's really helpful.
When would it be?
Like, imagine you're auditing your orders, right? You want to be absolutely sure that every single order you have in your system, it actually have a matching customer in your database.
Makes sense.
A right join with the orders table on the right side, that would highlight any orders that are kind of floating out there without a valid customer ID.
Oh, I see. So it's about making sure your data is clean, consistent.
Exactly, that your data is clean and consistent.
Okay, so now we've got inner, left, and right joins.
Right.
What about those times when we want to see everything?
Everything.
All the customers, all the orders, no matter what.
Well, for that, we've got the full join, sometimes called the full outer join. It's designed to bring back all those rows from both tables,
Okay.
whether they match or not.
Even the misfits.
Even the misfits. And if a row in one table doesn't have a match in the other, you guessed it, those missing columns will just be NALL.
Okay, so like a combination of a left and right join.
You got it. You'll see all the customers, their order details if they have any, all the orders, customer details if they exist. It's a very comprehensive view.
And the query, select customers.name, orders.orderdate from customers, full join orders on customers.customerid equals orders.customer.
That's it. And, the full join, it can be really helpful if you're trying to spot any inconsistencies in your data.
Yeah, like maybe you have an order without a customer or a customer who's somehow slipped through the cracks.
Exactly. It helps you find those anomalies.
Okay, we've tackled inner, left, right, and full.
Right.
There's one more on the list. This one sounds a little different, the cross join.
Ah, yes,
Yeah.
the cross join. Now, this one works a little differently. It doesn't need a matching column. You know how the other joins use that on-end clause to link things up? Cross join. It doesn't care about that. It just gives you every single possible combination of rows from the two tables.
Ugh.
It's called a Cartesian product.
Oh, okay, so if you had 10 customers and 5 products, a cross join would make 50 rows.
You got it. 50 rows, each customer paired up with each product.
Wow. That sounds like it could create a lot of data really quickly.
Yeah, you got to be careful with this one.
When would you actually use that?
Well, honestly, it's not as common as the others, but it does have its uses.
Okay.
Imagine you're doing some complex analysis, right? And you need to generate all possible pairings of things before you start filtering them down.
I see.
Like maybe you're trying to figure out all the different discount combinations you could offer on all your products, before you actually decide on a pricing strategy.
Interesting.
Or maybe you're setting up a temporary table with all possible combinations of some data points.
So it's more for those niche scenarios.
Yeah, I'd say so.
Okay, so quick recap of the join world. We have Inner join for finding those perfect matches. Left join for keeping everything on the left and bringing in matching data from the right. Right join does the opposite. Full join shows everything from both sides.
Right.
And then we've got the cross join,
The combinator.
all the combos.
Exactly.
Now, those joins, they're like the mechanics, the how we combine data. But the real magic happens because of how our tables are connected, right? Those relationships between tables.
Absolutely.
That's the foundation.
The relationships are key. And they usually rely on primary keys, those unique identifiers for each record, and foreign keys, which link tables together by referencing those primary keys.
Right, like the customer we've been talking about.
Exactly.
And these relationships, they're not all created equal either.
Right.
You've got one-to-one, one-to-many, and many-to-many.
It's all about how those tables are connected.
So let's break those down. One-to-one.
Okay.
What's that about?
One-to-one is the most straightforward. Each row in one table is linked to just one row in another, and vice versa.
Gotcha.
It's a very exclusive pairing.
Can you give us an example of where we might see that?
Sure. Imagine you have a users table that stores basic login information, usernames and passwords. And then you have a separate user profiles table with all the extra details, like addresses and maybe profile pictures.
Okay.
In a well-designed database, each user should have one and only one profile, and that profile should belong to just that one user.
Okay, makes sense. It's like a one-to-one match, direct connection.
Exactly.
Now, what about one-to-many? This one feels like our customer and orders example, right?
You got it. One-to-many is super common. One row in a table can be linked to many rows in another table, but each row in the second table can only link back to one row in the first.
So one customer, many orders.
Many orders. But each order belongs to just one customer.
It's like a parent-child relationship almost.
Exactly.
Okay, that one's pretty intuitive. Many to many, that sounds a little more complex.
It is a bit trickier. In a many-to-many relationship, you can have multiple rows in one table linking to multiple rows in another. It goes both ways.
Okay.
So think of like students and courses. One student can be enrolled in many courses, right? And one course can have many students.
Right. So how do you actually model that in a database?
Ah, good question. You can't just use a single foreign key. You need something called a junction table. It's basically a go-between.
A go-between.
Yeah. It sits in the middle of those two tables and connects them.
So for students and courses, we'd have a table called like student courses.
Exactly. And that table would have the studented and the course side linking them together.
Ah, I see. So that one table can have multiple entries for the same student, showing all their courses, and multiple entries for the same course, showing all the students.
Precisely. It's like breaking down that complex many-to-many relationship into two simpler one-to-many relationships.
And it's all neatly organized in this middle table.
Right. It's the standard way to handle many and many in relational databases.
And you've even got the SQL code for this, right?
I do. Let's take a look.
All right.
So first, we've got our students and courses tables. Pretty standard, each with a primary key for unique identification. SQL. Create table courses. Studented NT primary key. Name varchar 100. Create table courses. Course ID NT primary key. Course name varchar 100.
Okay, so studented in the students table and course aid in the courses table. Those are our primary keys.
Exactly.
Now, what about that student courses table? How does that look?
Okay, so here's the student courses table. Studented INT, course ID ID. Primary key, student and course ID. Foreign key, references. Studented references course ID.
All right, so we've got both studented and course aid in there, and it looks like the primary key here is actually a combination of both.
Right, that's called a composite key.
Composite key, okay.
It makes sure that we don't accidentally record the same student in the same course twice.
Makes sense.
And then you see those foreign key lines.
Yeah.
Those are super important.
Yeah. What are those doing?
They're what actually make the connection between the tables. Studented in this table, it has to match a valid student in the students table. Same for the course aid. It's about making sure our data is consistent. No phantom students or courses floating around.
Right, so it's enforcing that relationship. It's got to be a valid student, a valid course.
Exactly. It keeps everything nice and tidy.
Okay, I think we've got a pretty solid grasp on those relationships now. But how do these all come together in the real world? Let's imagine we're dealing with an online store.
Okay, that's a great example.
We've got our database with customers, orders, products, maybe even categories for those products.
Right.
So first up, how would we get a list of each customer and all their orders, the date they placed them, and how much they spent?
Okay, so for that, we want to use an inner join
Mm-hmm.
between our customers and orders tables.
Mm-hmm.
And we'd connect them using that trusty customer.
All right. What would the query look like?
It would be SQL Masterclass. Select customers.name, orders.orderdate, orders.total amount, from customers. Inner join orders on M, customers.customerred, orders.customerred.
Okay, so that's pulling the customer's name, order date, and the total amount from those two tables, matching them up based on the customer. And
That's
because
fine.
it's an inner join, we're only going to see those customers who have actually placed orders. Right?
That's right. Only the ones with matches in both tables.
Now let's flip the script a bit. What if we wanted to see all our customers, even those window shoppers who haven't bought anything?
Okay. For that, we would want to use a left join. That way, we keep all our customer records, even if they don't have a matching order.
Okay, so customers would be our left table.
Exactly.
What would the query look like for that?
All right, so here's how you'd write that query. SQL REO, select customers.name. From customers, left join orders on customers.customerred orders.customerred, where orders.ordered is null.
Okay, so we're doing the left join to get all customers. Then we're adding this extra piece at the end, this where orders.ordered is null.
Right. That where clause, it filters our results to show only those customers where the ordered is NELL, which means they haven't placed an order.
Ah, so it's like a double check to make sure we're only seeing those who haven't ordered yet.
Exactly. It's a really helpful way to find those inactive customers.
So we're using the left join to include everyone and then filtering down to just the ones we're interested in.
Precisely. It's all about choosing the right tool for the job.
Okay. Now what about connecting products to their categories? Let's say we have a products table with a category and then a separate categories table with the category names.
Boy, yeah, classic example.
How would we list out each product and its category?
For that, we'd go back to an inner join. We want to see products in their categories only if there's a match in both tables.
Makes sense.
So the query would look like this. SQL select products.product name, categories.category name, from products, inner join categories, on products.category, categories.category.
Okay, so again, matching up based on that shared ID, the category, and making sure the connection exists in both tables.
Exactly. We want to be sure the product actually has a valid category associated with it.
These are great examples. I'm really starting to see how joins can be used to pull out all sorts of interesting insights from our data.
They're incredibly powerful tools.
Now, for anyone out there prepping for interviews, or maybe you just want to solidify your understanding, we know SQL joins and relationships are hot topics.
Oh yeah, they come up all the time.
So let's go through some common interview questions and, give some concise answers, kind of like a little cheat sheet.
Love it. Let's do it.
All right, first one, a classic. What are the different types of joins in SQL, and when would you use each?
Okay, so for that one, you got to be ready to lay out the 5 main types. Inner join, that's for getting only the matching rows. Left join gets you all the rows from the left table and any matches from the right, and nulls if there's no match. Right join does the opposite. Full join, that's the all-inclusive one. And then, of course, we've got cross join for all those possible combinations. And for each one, you want to give a quick example of when you'd use it, like we've been talking about.
Right, so inner join for reports, left join for customer analysis, and so on.
Exactly. Show them you understand the practical applications.
Okay. Next one, this is all about the nuances. What's the difference between an inner join and a left join?
The big difference there is that inner join is strict. It only includes rows that match in both tables. Left join, it's a bit more lenient. It includes all the rows from the left table and then only the matching rows from the right. If there's no match on the right, those columns will have NLs.
Okay, one's about shared data, the other's about a complete view of one side.
That's a great way to put it.
All right, how do you handle many-to-many relationships in SQL?
This is where that junction table shines. You got to explain how you use that intermediary table with foreign keys that reference the primary keys in the 2 main tables. It's about breaking down that complex relationship into 2 simpler ones.
Okay. Now for a slightly trickier one, what's a self-join, and when would you use it?
Self-join, that's when you join a table to itself. It sounds a bit strange, but it's actually really useful for comparing data within the same table.
When would you actually do that?
Like if you have an employees table and it has a manager column that points back to another employee who's the manager, A self-join would let you find each employee and then also show their manager's name from the same table.
Ah, that's clever.
Yeah, it's a neat trick.
Okay, performance. We always got to think about performance. How do you optimize SQL join queries?
That's a great question, and there are a few key things you can mention. First, indexes. Make sure the columns you're joining on have indexes. That'll speed things up big time. And be selective with your columns. Don't just use select and pull back everything. Only grab what you actually need. And filtering early using where clauses, that can really help too. It reduces the amount of data the database has to process.
Smart strategies.
Keep it efficient.
All right, back to join types. What's the difference between a full join and a cross join?
Okay, so full join, it's all about bringing in all the rows from both tables, whether they match or not. Cross join, it's about making all the possible pairings, regardless of any matching conditions. One's about completeness, the other's about combinations.
Got it.
Two very different purposes.
And often we need data from more than just 2 tables. How do you retrieve data from 3 or more tables?
You just chain those joins together. Start by joining 2 tables, then take that result and join it with another table, and so on.
Okay, so it's like building a chain, connecting those data sets step by step.
Exactly, like links in a chain.
Now let's get specific about the syntax. What does the on-end clause do in a join statement?
The on-end clause, that's your rule book. It tells the database how to match up rows from the different tables. It's where you say, hey, connect these rows when this column from table A equals this column from table B.
It's the criteria for the join.
Exactly.
And in the real world, data's messy. How do you deal with NLs in joins?
NLLs. Well, when a join doesn't find a match, those missing columns will show up as NLL. To handle them, you can use the ISNLL or isNotNL operators in your where clause to filter things down.
Okay, so those operators give us a way to specifically target those NL values.
Right. You can decide if you want to include them or exclude them.
Okay, another one about join types. What's the difference between a natural join and an inner join?
Natural join, it tries to automatically join tables based on columns that have the same name. But, to be honest, it can be a bit risky if you're not super careful. An inner join, you're being explicit. You're telling the database exactly which columns to join on using that on-end clause.
So it's about clarity and control.
Exactly. Be explicit.
All right, back to that self-join concept. How do you actually write a self-join query?
You got to use aliases. Give the same table different nicknames so you can treat it as 2 separate tables.
Nicknames for tables, interesting.
Yeah, it's just a way to keep things straight. And then you use those aliases in your from and join clauses and define the join condition based on the relationships within that same table.
Okay, so aliases are our friends.
Absolutely.
All right, last one for now. Another fundamental SQL concept. What's the difference between join and union?
This is a big one. Joins are for combining columns from different tables. Unions are for combining rows from different select statements. One's about adding columns, the other's about adding rows.
Got it. 2 different ways to combine data.
Right. Different tools for different purposes.
Okay, so we've covered a ton of ground here. Let's do a couple of real-world scenarios to see how you might apply these concepts.
Sounds good.
All right, first scenario. You need to get a list of all customers and their orders, even those who haven't ordered anything.
That's a classic left join situation.
Okay, how would you write that query?
It would be .sql.
Okay.
Select customers.name, orders.orderdate. From customers. Left join orders on customers.customerid. Orders.customerid.customerid.
Okay, so we're using the left join to make sure we capture all those customers, even those without order.
Exactly. We want everyone from the customers table, and then we see if they have any matching order data.
Perfect. Now for scenario 2. You've got an employees table with name and manager id.
Okay.
How would you write a query to find all employees and their manager's name?
This one calls for a self-join. We need to join the table to itself, using aliases to make it clear which instance of the table we're referring to.
All right, so aliases are key here.
Exactly. So the query would look like this. Select E1.name as employee, E2.name as a manager. From employees E1, join employees E2 on n E1.managerid equals E2.employeed.
Okay, breaking it down, we're giving the employees table 2 aliases, E1 and E2.
Right.
And then we're joining them based on the condition that the manager in E1 matches the employee in E2.
Exactly. That way, for each employee, we can pull back their manager's name from the same table.
Very clever. So we've successfully navigated the complex world of SQL joins and relationships. I hope everyone listening feels more confident in their understanding of these crucial concepts.
Absolutely. They're essential for anyone working with relational databases.
And in our next deep dive, we're going to shift gears and explore the world of aggregations and grouping in SQL. We'll be looking at how to summarize data using functions like count, sum, avg, and of course that powerful group by y clause.
Yeah, that's where you really start to turn your raw data into insights.
So if you're curious about SQL joins or relationships, if you have any burning questions, or if there are other SQL topics you'd like us to dive deep into,